Today we're going to turn our volume around and do what I like to call the backwards problems. In other words, instead of being given the height and radius of a cone or a cylinder or just the radius of a sphere and calculating the volume, this time we're going to be given the volume and one of the other dimensions, or in the case of the sphere, just the volume, and be asked to find the missing dimension. So to start this, let's go back to our box, to our rectangular prism. And remember, in order to find the volume of the box, you would take the length times the width times the height, and that would give you volume. But notice in this problem, the height is missing. And instead, I've given you the volume. I kind of like have given you the answer, and I'm asking you for one of the pieces to get to that answer. In order to do what I like to call these backwards or missing dimension problems, the first thing you want to do is start with your formula and substitute in what pieces you have. So this time the 140 is going to take the V spot, and the 4 and 5 will take the L and the W, the length and the width. So I have 140 equals 4 times 5, H, and I'm looking to solve for H. A little confusing here, but I know that 4 times 5 equals 20, and that helps clean up that side. Now to get the H by itself, remember that the opposite of multiplying would be to divide. So you're going to see me divide both sides by that 20. We're solving a one-step equation. And when I take 140 divided by 20, I get the number 7. So my height is 7. And notice that my units are not cubic units because this isn't a volume, it's your height. And when you talk about how tall you are, you don't talk about being a certain height, inches cubed. It's just straight units. So as we move on to our circular volumes, we're going to do the same thing. We're going to start with our formula. We're going to substitute in what we know is given, and then we're going to solve for that remaining unknown, that variable. So let's start with a cone. This one is all done out for you, so let's just start up and notice we're gonna start by putting our formula. A cone has a radius of 6 inches, a volume of 565.5 inches cubed. What is the height? We're going to round to the 10th. First thing I'm going to do is get that cone formula written out, and I'm now going to take out variables and substitute in their values. And this time, the V is going to leave, and 565.5 is going to take the volume spot, equals 1/3 pi, and the radius, the R, is going to leave, and 6 is going to take the R spot. There is no height in the problem. That's my unknown, so the H stays in the formula. And what I'm going to do is just clean this up a little bit. So remember that 6 squared is 6 times 6, or 36. And to multiply by 1/3 is the same thing as dividing by 3. So 36 divided by 3 cleans up to 12. So I have 12 pi being multiplied by H. Now, one way to do that is to right now divide both sides by 12 pi. You're going to notice a little note here. Make sure that when you do that, you have parentheses around it when you enter it in the calculator, or you won't get the right answer based on what the calculator thinks you're doing for order of operations. So we're going to pick up our calculator. We're going to take 565.5 and divide it by now parenthesis 12 times pi end parenthesis. So make sure you put those parentheses in. Try that in the calculator, even if you have to pause the video for a second. And please make sure that you see that it is about, if we round to the 10th, 15 inches. And again, your unit is straight units because you're talking about how tall is the cone, not its volume, not how much stuff is in it. Please just make sure, like I said, if you have to pause the video, and make sure that calculator-wise you understand how to do this division and you do get the 15.0. Okay, let's take another example. This time we don't have a cone, we have a cylinder. The volume is 100.5 inches cubed. Now, wait a minute, Mrs. Wood, if I don't see the word volume in there, but look at the units. Because they are cubic units and it's talking about holding that, that is your volume, and that's why units are so important. As soon as I see that cubed, I know this is the V. The radius, again, from the center to the outer edge is 2 inches, and we need to know what the height. So this time we're looking for the height. First thing I'm going to do is put that volume of a cylinder formula up there, and I'm going to make some substitutions. The 100.5 is going to take the V spot, and the 2 is the radius, not the diameter, so the 2 can go right in for R, and this is where I'm starting. 2 squared is 4. And notice I have 4 pi multiplied by h, so I'm going to divide both sides by that 4 pi. And look at those parentheses, guys. You want 100.5 divided by parenthesis 4 times the pi button, end parenthesis, and hit equals. Pause the video, try it on your calculator. Let's make sure we're going to get the same answer. All right, so when I took the 100.5 divided by the product, the multiplication of 4 pi, and I showed the calculator that by putting it in parentheses, you should have gotten about 8.0 is the h. Now, our units here are inches, and since this is the height, it's straight units, not squared, not cubed. So the height of the can is about 8 inches. Are you understanding what I mean kind of by the backwards idea? In that we're kind of having to solve for one of these pieces rather than just multiply to get the volume. Okay, let's do another cone. A cone-shaped weight, so this is kind of like a paper weight or something like that, displaces 350 inches when it is placed in a tank of water. Notice the units there. It's talking about displacing. What does that mean? Well, when we put this in water, its volume will be displaced. That means it would come out. So that is a volume, inches cubed. The cone has a diameter. We got to be careful. Diameter of 8 inches. Find the height of the cone. First thing I'm going to do is going to get that blank formula there. There is the volume of a cone, 1/3 pi r squared times h. The V leaves. The 350 will take its spot. And careful, we need a radius. Since we have a diameter, the diameter is the big guy. We need to cut him in half to get the radius. So do you understand these substitutions? Okay, I'm going to do a little bit of cleaning. And this time I'm going to show you, instead of keeping the pi in there, we could approximate before we divide, and that's what I'm going to show you this time. So 4 squared is 16, and 16 divided by 3 doesn't give me a whole number, or really a nice number. So what I'm going to do is actually approximate that. So 16 divided by 3 is 16.76-ish. Divide both sides by that, and I get about 20.9, in this case, inches. So you don't have to keep the pi in there when you divide. You could approximate. Notice I'm kind of keeping out to the hundreds just to keep a little more accuracy in there. Final answer, though, I'm going to round to the 10th. You'll see 1 decimal place there. I'm going to just do one last problem here today before I let you give it a go. Tonight, we're just looking for missing heights. Our second day of missing dimensions will deal with what if the radius is missing. So tonight, or today rather, on the problems, there won't be any spheres yet. That's coming tomorrow. So the figure below, you've got basically a cylinder sitting inside of a cone. The cylinder has a radius of 2. The cone has a radius of 4. The height of the cone is 10. I just want to make sure you see that picture. For the figure below, find the height of the cylinder. So the height of this purpley blue cylinder is missing. We're going to kind of have to take 2 steps to get there. Note that the volume of the cylinder is less than the cone. It's 1/2 the cone. So I'm looking at this and thinking, well, I don't know where to start, but what I could do is at least find the volume of the cone. I've got its radius. I've got its height. I could find that. Be careful, I need 1/2 of it. And then I would have a cylinder with a radius of 2, and I'd know its volume, and I would do a backwards problem. So what we're going to do is we're kind of going to do a frontwards problem first and a backwards problem second to get a final answer. It's 2 problems in one. We're going to start by finding the cone volume. So here comes my formula. I know that the radius of the cone is 4, and I know that the height is 10. So this is a straight volume problem. So I'm going to make my substitutions. 4 squared is 16. 16 times 10. Divide it by 3. multiply it by pi, and I'm going to get it's about 53.3 pi as my exact answer. So 16 times 10 divided by 3 is about 53.33333 pi. That's the volume of the cone, but the cylinder is half of that. So I'm going to divide this by 2, and the cylinder would have a volume of 26.66666 times pi. Okay, now I need to know the height of the cylinder, so I really don't care about the cone anymore. I'm going to use this volume as the cylinder, and I'm going to use his radius of 2. Here is my cylinder formula. Notice I always write that first. This time the 26.6 repeating pi is going to come right here. The 2 is going to take the radius spot. How does that look? Now to get the h, I'm going to divide both sides by 4 pi. And kind of cool when we do this, if you leave it as a pi, pi over pi cancels. And 4 pi over 4 pi cancels. So all I have to do is take 26.66666, divide it by 4 in the calculator, and the height of the cylinder is about 6.6 repeating, or 6.7 units. And of course it should be smaller than the cone, because the cone was 10. So, from the base of both the cone and the cylinder to the top of the cylinder would be about 6.7. So there's an example where we're doing a frontwards problem to get the volume and using that volume answer to get the height of a second figure. So I hope this gets you started doing some little bit more challenging backwards problems, finding the missing dimension in volume. So give it a try.